Hello everyone. Today we are going to take up the first chapter in the CBSE syllabus for class 9th, and that's motion. And we will be taking it up in with reference to the Eduwiser CBSE Physics for class 9 book. And let's start this whole topic, and we will be concentrating only on the topics that have been covered, that have to be covered under the NCERT syllabus. We will be taking them to a higher level, to a more foundation level, where you can really appreciate the finer nuances of the concepts that you have to master in this particular class. Rest and motion. The first and the foremost thing that we are going to study in this chapter is about rest and motion. In layman terms, what is rest and what is motion? Anything that is not moving is said to be at rest, and anything that you can see is moving is called a body in motion. So that is the layman difference between rest and motion. But if you delve deeper into this, you will find many anomalies. For example, when I see something moving, I call it a body in motion. What about the earth? Isn't it moving around the sun? But can we see it? Can we perceive it? Of course not. We can't see whether the earth is rotating or it's revolving or not. For us, it appears to be stationary. Everything that's there on the earth, it appears to be stationary to us. So how does our definition of motion change in that case? We can't say that it's a body in motion, that we can see it with our eyes. Such kinds of motion which are not perceptible, which are not perceived by human eyes but are still there, are called imperceptible motion. Examples of such motion could include the expansion of the universe, the revolution of the earth, the motion at a microscopic level, among other things. Now, for observing these imperceptible motions, you need to have special tools. For example, if you want to observe the movement of a microorganism, you need to have a microscope to actually view it. So imperceptible motion is not perceivable directly through the eyes, but through special tools. So within motion there could be perceptible motion as well as imperceptible motion. Now again, the concept of rest and motion, if you go deeper into it, will have to be refined when you are studying physics. I'll explain it to you through an example. Now consider this example here given on this screen. It's about a bus in which two people X and Z are sitting, and there is a person Y who is standing on the footpath and observing them. Now when the bus moves in any particular direction, what will Y say about X? He will say that X is moving. But what will Z say about X? If X does not move from his seat in the moving bus, what will Z say? Z will say that X is at rest. So for Y, X is in motion, whereas for Z, X is at rest. Now who is right? If the definition for rest and motion were correct, that a body that is not moving is said to be at rest, what should we call X? Now this anomaly can be explained if we define the frame of reference. Whenever you are defining a body's position to be at rest or in motion, you have to first choose a reference frame. Once you choose a reference frame, with respect to that frame you can state whether a body is at rest or motion. Hence, the concepts of rest and motion both are relative. Let's see how. Now you have a frame of reference. A reference frame is something that's attached to the person who is observing it. So for the reference frame that's attached to Y, X is moving. So X is moving with respect to the chosen frame of reference, that is Y. So when we have to talk about the rest or motion of body X, we have to define it with respect to Y or Z, which would be the two chosen frames of reference for us here. So X is in motion with respect to Y, and X is at rest with respect to Z. So the definition of rest and motion is not absolute, it is relative. And relative would mean that we have to first define the reference frame from which the observation is being made. Here the observations are being made by Y and by Z. Hence, when we state X's position, we say that it is in motion with respect to Y, and it is at rest with respect to Z. So this is how you define the position of any body. Rest and motion are not absolute, they are relative. Now in this particular class we will be taking up motion along one dimension. That's one dimension motion, or motion along a straight line path. That straight line path could be horizontal or vertical or in any direction, but it will be a straight line path. The path cannot be zigzag. So, a particle, the motion of a particle that we are going to study is only going to move in one straight line, back or forth, but in one straight line. So, we are going to study the position of an object on a straight line path. Now, in the example given here, you have a railway station, you have a radio station and a bus stand at 3 different locations along a straight line path. The radio station as well as the bus stand are 3 kilometers away from railway station, but on opposite sides. Now, if I say that person A has gone 3 kilometers, where is the person A at the end of 3 kilometers? Would you be able to define it clearly? You will not be. You will not be able to know whether he is at the radio station or is he at the bus stand, because I have not stated in which direction is he moving. But the information of motion would be complete if I say that the person A has moved 3 kilometers to the east. In that case, you would know that he has reached the radio station. If I say that he has gone 3 kilometers to the west, that means you would be certain that he has reached the bus stand. So, for any kind of one dimensional motion, it is important to define a few things to absolutely tell what the position of that object is. The first thing is the choice of origin. You have to define what your origin is, or the point from which the reference or the measurements have to start. So, the origin is the point in the chosen frame. Origin is the point from where you have to do your calculations. One side of it will be positive and the other side can be taken negative. It is not mandatory which side will be positive and which would be negative. You could take the right side to be positive and the left to be negative, or the vice versa. It is not important that way, but you have to know that one side of the origin is going to be positive and one side of the origin is going to be negative. This will help us know the position of an object on a straight line path. So, if we know the position of the object, for example, in the figure given here, there are 3 people A, B and C. If I have chosen an origin that is at O, and if I say that A has moved plus 1 kilometers, based on the choice of positive direction and negative direction, I can specifically state A is on the east or on the west of the point O. So, when I say A has moved plus 1 kilometers based on the choice of positive direction which I have taken towards the east, we can state that A is 1 kilometers to the east of O. If I say B has gone plus 3 kilometers and C has gone minus 3 kilometers, what does it mean? It does not mean he has travelled negative distance. It just gives you a sense of direction. The plus and the minus, that is prefixed when we define the position of an object on a straight line path. It does not signify its magnitude, it just signifies its direction. So, it just tells you on which side of the origin has the body moved, once you have defined the direction, positive direction and the negative direction. So, here the east direction is taken to be positive and the west direction is taken to be negative. So, when I say that B has moved plus 3 kilometers, that means it has moved 3 kilometers to the east of the origin O. And when I say that C has moved minus 3 kilometers, it just means that he has moved 3 kilometers to the west of origin O. It does not mean that he has moved minus 3 kilometers, because minus 3 kilometers is no value. Now, the next important concept is distance and displacement. What is the difference between distance and displacement? Distance, a body moving from a point A to B can move in several paths. It may not be a simple straight line path. He could move in a zigzag manner, in a curvy manner, or he could take several rounds before reaching B. So, the length of path that it traverses to reach the point B is referred to as distance. Distance is the length of path traversed when a body moves from point A to point B. So, you have to take all the small, for example, in the given figure you have a curvy line, right. So, the distance moved from A and B on that curvy line would be the length of the entire curvy path. So, that is the length, that is the distance, it is the length of path traversed by a body as it moves from a point A to a point B. And what is displacement? Displacement is the shortest distance between the initial and final points. So, essentially it is the straight line joining the initial and final points. So, irrespective of the path that the person takes, displacement is always going to be the shortest distance between the initial point from where he starts his journey and the final point where he ends his journey. So displacement in the given figure will always be the line AB, not the whole curvy thing. So what do you see? The distance has to be the whole length of the path traversed, but displacement will be irrespective of the path traversed. It will always be the line joining the initial and the final points, which is always going to be a straight line joining the initial and final points. So in this particular case, or in any case that you observe, the distance will always be greater than or equal to the displacement between 2 points. Why is that? Because displacement is always going to be the smallest path. Distance could be the smallest path, or it could be any other path that the body can take. So distance will always be more, or at the most it could be equal to the displacement. When will the distance and displacement be equal? They will be equal when the body moves in a straight line path from point A to point B. That is, if it moves in a straight line path from the initial point to the final point, the distance in that case is going to be same as the displacement, only in one direction. If he goes from A to B and comes back, then the distance and displacement would be different. So you can easily state that the displacement of a body moving from point A to B is always going to be less than or equal to the distance traveled by the body in moving from point A to B. Now, if a person goes from A to B in a straight line path, if person A goes from A to B in a straight line path, he stops at B. That would mean that the initial and the final points are A and B. In this case, the distance and the displacement are going to be the same, because the path that he has taken is a straight line path. So the length will also be that shortest path joining A and B. So in this case, the distance and displacement are both going to be the length AB. What happens if he goes from A to B and then comes back from B to A? In this case, the length of path that he has traversed would be AB plus BA. That is 2 times the length of the line AB. Whereas the displacement, the definition of displacement is that it is the shortest distance between the initial and final points. Initial point was what? A. He went to B, which was the intermediary point, and then he again came back to A and stopped. So the final point again is A. So if the initial point is A and the final point is A, what is going to be the shortest distance between these 2 points? It's going to be 0. A and A, there is no distance between, there is no length that is separating them apart. So the displacement in this case would be 0. So even in case of a straight line path, if the body moves and then comes back again to the original point, to the initial point, in that case the distance is not going to be the same as displacement. It is going to be more than displacement. So